All right, let's continue on with hypothesis testing for the difference between two means. Now we're going to be using confidence intervals. So we will still, even though we're using the confidence intervals, we're going to hypothesis test. We still have to do the null and alternative hypothesis, which will be a little different, then construct the interval, which we did in the last video, and then make a decision. So this is important here. We're going to reject the null if the difference value does not fall within the confidence interval. All right, so let's look at null and alternative hypothesis. So we're dealing with two means. What we're going to see is that we'll probably see in the textbook this here, but sometimes it's helpful to think about it in this way here. So we would probably start here and then move it into this here. So basically, if it's a two-tailed test, we're saying the two means are different, and then we would subtract mu2 on both sides, and then it would look like that there. So this may be a helpful way to start and then move it back into the textbook, and we'll do some examples. All right, so this is the previous example from the last video. We want to specify the competing hypotheses in order to determine whether the average nicotine levels differ between. So if we want to determine if they differ, so that means we want to say, okay, mu1 is not equal to mu2. And I'm not sure if you can hear my puppy eating behind me, but I'm sorry if that's disruptive. So, all right, we're saying that they differ. So mu1 is not equal to mu2. And then that means because of equality, this. But we can turn it into something where we can see the difference value. And we want the difference value because we want to know if it's inside the confidence interval. So if I subtract mu2 from both sides, we would see that we get 0 left over here, and then 0 over here. So here is our null and our alternative hypothesis. So now for B, it says using the 95% confidence interval, what is the conclusion to the test? So let's recall from the previous video that the confidence interval was between these two values here. And again, we don't need to do it again. We did it in the previous video. So what is the conclusion to the test? So let's go back here. If we want to make a decision, we reject if the difference value is not in the confidence interval. So let's see. Basically, we want to know is that whatever value here inside. So is 0 inside in between these two values? No, they're both negative. So if you kind of think about a number line, 0 is over here, and we're talking about negative values. So the value does not fall within the confidence interval, so we're going to reject. So we are going to reject the null. So if we reject the null, we say, hey, we're rejecting this, then we can say, hey, there is sufficient evidence to say that there is a difference, to say they differ. The nicotine levels differ. And if you want to see that written out a little bit clearer, here you go. Now go ahead and give this one a try, and you'll need to use your previous work from the previous video because you've already done this problem in the previous video. So continue on to B and C and press play when you're ready to see the solution. And there you go. So now we're just hypothesis testing. Now we're not going to be doing a confidence interval. We're going to do p-value method. So we need the test statistic and the p-value. Now, we're going to need a different formula for the test statistic. And the p-value, I'll just remind you how to do that again. So if we're given data, we're going to use Excel. And this is really important here, y'all. You've got to take a moment, pause, make sure you have your Microsoft Office Excel, and you need to go ahead and go through and install your analysis tool pack. So pause here. And the idea is that you should be able to see your data analysis when you click on the data tab. Once you've added that, you should go over to data, and you should see it all the way over here in the far right corner. So you will need to do that add-on. Feel free to Google to find other resources to help you get that in, but you will need to move away from Google Spreadsheets now into Excel. All right, so for the test statistic, again, if we know the variance, if we know the variance, we'll use this formula for the test statistic. If we are given data values, we're going to use Excel. If we don't know the variance, but we assume that they're equal, then we'll use this formula here. And again, if we are given data values, we can use Excel. And again, whoopsies, unknown and not equal, then the test statistic will be right there. And for Excel, we'll use that. So here they all are. I would definitely make sure you've got these written down. Now, just a reminder, how do you calculate the p-value? If we're talking about a z-test statistic, you'll use the normal distribution, a t-test statistic this way. Now, remember that Excel gives you to the left in a z-test and to the right in a t-test. So if you're someone who's like drawing curves and making sense of these, don't forget about that. If you're someone who likes to memorize formulas, then you don't need to worry about that. All right, example 3. So we're talking about an economist claiming the average weekly food expenditure for households in City 1 is more than the average weekly food expenditure for households in City 2. So we've got all this data here, and we've even got the population standard deviation, all right? And from that standard deviation, we can square it and get the variance. So now, A, specify the competing hypotheses to test the economist's claim. So for A here, what's going on? What's the economist's claim? They claim that City 1 is more than City 2. So City 1, City 2. So they claim, and more than doesn't have equality, so I'll start there. They claim this. And so the opposite there would be that. This is the claim. But we're going to make it so we can see the difference value. So we're going to just subtract mu2 on both sides. And if you can go straight to this, you're more than welcome to do that. But so these are our alternative and null hypotheses. So in this case, we know the population variance because I can square both of these values to get the population variance. So let's go and pick our test statistic. So because we know, we're going to use this first one here, and we're going to grab these values. So we're going to use this formula here. And let's double check that we've got everything we need. So our test statistic is going to be equal to x1 minus x2 minus the difference value here is 0, all over the square root of, the variance here would be 12.5 squared over 35 plus 9.25 squared over 30. So go ahead and type this in your calculator, press pause so you can do the problem with me. But I do the top and then I do the bottom, and I get 1.85 is our test statistic. So that's B wants our test statistic. So this is our test Z. So if you're thinking about, okay, what does that mean? We know we're looking at 1.85, and we've got a right-tailed test here. So our p-value is going to be right in there, that probability amount. So remember that the Excel gives us back to the left. So if we want to figure out the p-value, we need to do 1 minus. And again, if you're someone who is a formula person, you just use the formulas that are there. So we're talking about a test statistic of 1.85, standard normal. So that is our p-value, 0.032. All right, and maybe you want to grab one more too. Okay, so that's our p-value. So we've done that. At the 5% significance level is the economist's claim supported by the data. So at the 5% significance level, so let's compare p to sigma. So our p-value is 0.0322. How does that compare to sigma? So first digit, the same. Second digit, this is our p. This one, 3 is less than 5. So the p-value is lower. So if the p is low, the null must go. So we're going to reject our null. So if we reject our null, we're supporting our claim there. So we can actually support the economist's claim that City 1 is more than the average of City 2. And here it is written out for you. And we'll do one more example here with Excel. So we've got these firms here, and we want to conclude at the 5% significance level that the average returns differ. So we want to say that they differ, so not equal to. So mu1 is not equal to mu2. That's what differ. So we can say, all right, that their difference is equal to 0. or that their difference is not equal to 0, and that is our claim. So we have installed our data pack here, so let's go ahead and use it. So to get our test statistic here, we don't know anything. The population variances are equal. That's what we know. We don't know them, but we assume they're equal. So that's important to remember. So now let's go into our Excel. I'm actually going to see if I can make this a little bit bigger. Let's see. So I am going to click over to Data, click into my Data Analysis. It's going to let me in. Okay, I had to put it over in a new Excel file. So let's see here. We're in, let me make this a little bit smaller so you can see. Okay, so we are going to go into Data and then over to Data Analysis. And we're going to go all the way to the bottom. And we have 2 samples, and we are assuming they are equal variance. So they're unknown. Oops, let me just double check here. And, oh, excuse me, this is super important. I was like looking at my notes. We cannot assume that they are equal, so we're going to assume they're unequal. So unequal variances. And now for 1, we're going to highlight all of that, and we do have labels on it. And for our second variable, we've got oil. And our alpha, what's our significance level here? We're talking about the 5%, so we'll keep 0.05. We'll click OK. And then it produces a new sheet here, and you can make that a little bit bigger so you can see, or maybe you're like, ah, too big. And what we're looking for here is our stats, our T statistic. So that is our test statistic, negative 0.302. So our test T is negative 0.302. And we want our p-value. And we need to say, okay, what kind of tailed test is this? This is a 2-tailed test. Let's go back here. So this is a 2-tailed, so it's going to be, our p-value is 0.766. All right, so now how does our p compare to our significance level of 0.05? Well, right away we can see that 7 is more than 0, so it is greater than, so we do not reject the null. And so that means we're going to support the null, so we cannot support the claim that the 2 firms, the returns are different. So you can take a look here to follow along. And go ahead and give these 2 problems a try. One with Excel, one without. Remember, if you have data, you can use Excel. If you don't have raw data, you've got to get your test statistic manually. And those are the solutions. And that concludes 10.1.